We will be graphing radical equations functions. And the one that we went over in class is this one, which was square root of x. And here I'm showing you the graph. This is exactly what we did in class when we found the table. And in our table, we found that there was a point 0, 0. Remember, we chose the x values and then we found for the y. And then in here, we got 1, 1. And when we square root number 4, it would be 2, and so on. And I want to start showing you what happens when we start doing transformations. So let's say, for instance, let me add a function. And I'm going to leave my square root of x as a reference. And I want to show you what happens when we take the square root of x. And then let's say, for instance, I want to add 3 units. So one way is for you to create a table, assign values to the x, and then simplify the radical expression, and then add 3 units into it. And once I have that value, notice in here, the point that it was a 0, 0, it goes all the way to 0, 3. Everything that was at 4, 2, it went to 4 and 5. So I want you to notice this is called a vertical shift, that it increases everything by 3 units. Let me show you what happens if we have one more. Square root of x, and say, for instance, instead of adding a 3, I'm going to subtract 3 units. So let's see what happens to our graph. This is my original, and when I subtract 3 units, it shifts the whole graph 3 units down. One long way is to create a table. The shortcut is for us to learn how to remember about the transformations that are happening to our graphs. Let me get rid of these ones, and I want to show you another type of transformation. What would happen if I have the square root of x, and before I go outside the square root, I stay within the square root, and then I say plus 3 units. So if I look from the original, my purple line, and when we do the plus 3, it actually shifted to this point, which is -3, 0. So we're talking that the shift happened 3 units towards the left. What would happen if I add another one? And now in here I say the square root of x, and then instead of adding, I will subtract. Oh, sorry. -3. And I'm hoping that you were guessing that this graph actually started now at 3, 0. Now let me get rid of these 2 functions. And so this one is called our basic function, that it has no transformations whatsoever. Another one that I want to show you is what happens when we have a negative in front of a square root of x. This one was my original function, and when we graphed the negative of it, it actually reflected along, so it was a reflection about the x-axis and everything that it was. Well, this one it was 0, 0, but when our point was, say, for instance, 4, 2, it became a 4, negative 2. I have a summary of the equation or the functions that we just graphed. So the square root of x, this one is just our basic graph. This one, basic. And when we have the transformation of the square root of x plus 3, the way that we did it in class is, how about if we construct a table? So in here I wanted to show you what happens when we have a table. Remember that whatever we get from our f of x represents our y value. So the long way, it was assign values to x. So in here we have to determine what values can I assign to my x that has a square root. So we selected a 0, 1, 4, and 9. So we have to evaluate our function when x is 0 and then plus 3. And then we follow to complete this with pandas. And pandas will say, oh, okay, so we have to say this one will be equals to 3. Oh, sorry. Then we will have the square root of 1 plus 3 equals 2. Following pandas, we take the square root of 1, which is 1 plus 3. This one is 4. The square root of 4 plus 3 will follow the square root of 4 is 2 plus 3. This gives us a 5. And the square root of 9 plus 3 is equals to 3. This one plus 3 is equals to 6. So this is the way to create a table, or we must just focus on remembering that this plus 3, it has 3 units, which is completely outside the square root. So it will be 3 units shift upward direction. This one, it was 3 units shift. Oh, sorry, I'm making mistakes in here. So downward. And when the square root had a shift inside the radical, this one implied that if it was a plus 3, we're going to have 3 units shift to the left. Actually, it takes the opposite sign. In here, when it was minus 3, it would be 3 units shift to the right. And when we have a negative value outside the function, it had a special shift. So this one, we call it a reflection about the x-axis. So this one is a summary of transformations. Using the shifts, the understanding of how the units change the graph, how do they move, because if we construct the table, it's very long. this one takes too long of a time to be graphing for every single graph. So it's better to understand how the basic one works, and then from there we start working on the transformations. And this one would apply to any other graph. And we have many more functions to come, even graphs that are not functions.